Okay, guys, so we're working on page 57, questions 11 through 17. We might have done some of these in class, but that's okay. Let's just review them briefly and let's get going. So they wanted us to write the definitions and fill in the blanks here. So we have an octagon. Well, we know that an octagon is a polygon that has 8 sides. And if you put that, that's correct. But don't forget that it has 8 sides and 8 angles. Very important. It has 8 sides and 8 angles. The number of sides corresponds to the number of angles. Next, we have a concave polygon. Well, a concave polygon is a polygon that has at least one diagonal on its exterior. If all of the diagonals are inside of the polygon, then it is a blank. What do you think it is? If you answered convex, you answered correctly. Convex polygons have all their diagonals on the inside, and concave polygons have at least one diagonal on its exterior. Next, a 20gon is also called an icosagon, which is a polygon that has, if you guess, 20 sides and 20 angles, right again. And finally, an equilateral polygon is a polygon that, well, remember that equal means equal and lateral means side, from side to side, so is a polygon that has all sides of equal length. All the sides are of equal length. Let's move on to number 12. Number 12, they want us to name a pair of consecutive angles and a pair of consecutive sides. Let's do the angles first. Well, let's take a look here. Angle A and angle C are consecutive. Angle A and angle C are consecutive because they come one right after the other. Okay? We could also say that angle C and angle Y are consecutive. We can also say that angle C and angle Y are consecutive because C and Y come one right after the other. And we could also say that angle Y and angle N are also consecutive because they come one right after the other. And there are a couple of other choices we could put in as well. We're just going to do a few right now. Next, they want us to name 2 pairs of consecutive sides. Let's name a pair of consecutive sides. Okay, well, let's take a look here. Some consecutive sides. Well, here I have side AC. Here I have side AC or segment AC. Well, what would be consecutive with that? Well, I can say here that segment CY is consecutive. So these two would be consecutive with a this with AC. Or I could also say that segment AH is consecutive with AC. So segment AH is consecutive with segment AC. I can also say that segment CY is also consecutive with segment AC. CY is consecutive with segment AC. And there are a couple of other. We can use these out here, but right now we're just naming a few. Question: is segment AH consecutive with segment AT? Is segment AH consecutive with segment AT? Well, I'm sorry, it's not. AT is not even a side. AT is not even a side. AT is a diagonal, so that wouldn't work. That wouldn't work. How about segment AC? Let's try, let's take a look here. Segment AH and segment YN. How about segment AH and segment YN? Are those consecutive sides? Take a second to think about that. AH and segment YN. If you guess no, you guess correctly. Right again. These two sides are not consecutive. Okay, next question. The next question is asking us to draw a concave hexagon and how many diagonals does it have. To draw a concave hexagon and to see how many diagonals it has. Well, here I have a hexagon and I am going to kick in one side. I'm going to kick in this one side right here. Now something interesting happens when I do that. When I kick in my side, it's going to look something like this. Well, the hexagon has 6 sides if you count them. 1, 2, 3, 4, 5, and 6. And by the way, I am not using these dashes to indicate that these sides are in fact congruent. I'm just using that to count the sides. 1, 2, 3, 4, 5, and 6. Well, here I have now 1, 2, 3, 4, 5, 6, and 7. 7. So now I have 7 sides. So is this still a hexagon? The answer is no. It is not a hexagon. It is a heptagon. It is a heptagon. And the question wants us to create a concave hexagon. A concave hexagon. Well, wait a minute. When I had 6 sides and I made one of the sides concave, I ended up adding a side. Let's try that with a triangle. Let's try that with a triangle. Here I have a triangle, which we know has 3 sides, and we are going to make one side concave. We're going to make this side right here concave. Well, when I do that, my triangle is going to look something like this. Okay, I took the side, I concaved it. Well, wait a minute, how many sides does it have now? 1, 2, 3, and 4. So my triangle, when I made one side concave, became a quadrilateral. So basically the rule is this: if you take a polygon and you make one side concave, you're going to add an additional side to that polygon. And let's not forget here that the question was asking us to create a concave hexagon. Well, if we add a side every time you make a side concave, we can start with a hexagon. What shape do you think we have to start with? What shape do you think we have to start with? If you guessed a polygon, then you guessed correctly. We have to start with a, excuse me, did I say polygon? Forgive me. I said meant pentagon. We have to start with a pentagon. And if you guessed pentagon, you guessed correctly. Okay, because now we're going to take our pentagon and we are going to make this side. We're going to concave this side. We're going to cave this side in. And when we do that, our polygon is going to look something, or excuse me, our pentagon is going to look something like this. That was the wrong button. Let's try that again. Okay, there we go. Okay, so our pentagon is going to look something like that. And my sides now, it's going to look like this and like that. And now it is no longer a pentagon. If you count the sides, 1, 2, 3, 4, 5, and 6, my pentagon is now a hexagon. And what I have here is a concave hexagon. What we have here is a concave hexagon. Well, let's count all of the diagonals. Let's count all of the diagonals. How many diagonals do we have? Well, it's concave, so I know I'm going to have at least one diagonal on the outside. I'm going to have a diagonal right here, so that's 1. Okay, let's start with this vertex here. Let's start with this vertex here. Okay, let's see here. Well, this would be consecutive, so that wouldn't count. Okay, so there's 1 there. Okay, there's 2 there. And we already have this one here, and this would be consecutive. So really, with using this point, we only have 1 and 2. 1, let's put those in, let's leave them at 1 and 2. Next, let's use this point here. Well, that wouldn't count. This would be 1. This would be 2, because they are not consecutive. 2. This would be 3. And this would be consecutive. So we have 1, 2, 3, 4, 5, and 6. So far we have 6. Let's go from here. 6. That would be 7. This would be 8. 8. And from this point here, we already have, let's see, we have 1, we have 2. Oh, that's 8. Wait a minute, we're missing 1 right here. That would be 9. And I believe that covers all of the diagonals. We can't make any more diagonals that aren't already created. So we would have a total of 9 diagonals, ladies and gentlemen. 9 diagonals. Next question. Next question says, name the diagonals of pentagon ABCD. Name the diagonals of pentagon ABCD. Well, okay, well, here is my pentagon. First, let's make all the diagonals. Before we name them, let's make them. So this is 1, this is 2, this is 3, this is 4, and this is 5. So we have 5 diagonals in this convex polygon. Well, now let's name them. That should be pretty simple enough, right? Let's take a look here. The first one is AC. So we have segment AC. The next one we have is CE. So we have segment CE. Next we have EB. So we have segment EB. After that we have BD. Segment BD. And finally we have DA. Segment DA. A total of 5 diagonals, and we can see them all here. Next, the next question is asking us to use the information given to name the triangle that is congruent to the first one. So here we have triangle EAR. Here's E, here's, let me change the color, here's A, and here is R. If you remember, we talked about corresponding angles and corresponding and congruent figures, polygons. Well, wait a minute. If I have an EAR, well, that's, let me see here, E, that's 2 to 3 dashes to 1. So EAR, 2 to 3 to 1. Well, over here is going to be 2 to 3 to 1. Well, which one has 2 over here? Well, T has 2, right? I has 3, and N has 1. So my polygon would be congruent to triangle TIN. Pretty simple there. Next one we have triangle OLD. Triangle OLD is congruent to this triangle here. Well, let's take a look here. Here is the O. Here is L. And here is D. Well, let me pick a better color. Let's pick yellow. Okay. So here, OLD, I'm going from 3 to 2 to 1 dashes. 3 to 2 to 1. Well, which one has 3? W has 3. E has 2. And N has 1. So when I name my polygon, when I go to name it, OLD 3, 2, 1 corresponds to WEN 3, 2 to 1. Triangle WEN. Next question is a little bit challenging because now they're making it a little bit difficult for us. They want to challenge us a little bit here. It says in the figure to the right, this pentagon, let's see here, 1, 2, 3, 4, 5, Pentagon think is congruent to Pentagon power. And if you remember, we said that the letters correspond to the other letters in the order that they are written in their name, meaning that T corresponds to P, H corresponds to O, I corresponds to W, so on and so forth, and K corresponds to R. Okay, and they want us to find the measures of A, B, and C. Well, if we look here, let's find A first. Let's find the measure of A. Well, if you notice, A is between points W and O. So we can call this segment WO. Well, if I'm looking at the name here, WO, segment WO, and if they correspond, then that would be, the corresponding segment would be segment I to H. I to H. And if you look here, here's I, here's H, and that is 44 units. So we know that A is going to be 44 units long. Next we're looking for the measure of B. Well, let's take a look at the segment that corresponds to B. Well, B is between R and E. It's between R and E. So if we look in the name right here, well, here's R, the last letter going to E, the next to last letter. So then we know then that K would go to N. R corresponds to K, E corresponds to N, so K to N. So if we look here, well, here's K, and here's N, and segment KN is 58. So we know that B would also be 58. Okay? So we know that A is 44, B is 58, and now we're going to find C respectively. Okay? Well, C is between points P and R. P and R. Well, how does that correspond in the name? Well, P to R is from the first letter to the last letter. So we know that it's going to be from the first letter of think to the last letter, which is from T to K. Well, if we look here, here's T, here's K, and that corresponds to 34 units. So I know that C corresponds to 34 units. And we have found the values, the measures of A, B, and C respectively. A is 44, B is 58, C is 34. Now, they tell us that if the measure of angle P is 87 degrees and the measure of angle W is 165, which angles in think do you know? Write their measures. Okay? Simple enough. Well, let's take a look here. Here's angle P. Here is angle P, and we can call it angle P because we know that its vertex is not being shared with anyone else. So angle P is 87 degrees. So I know that if I took a protractor and I measured the distance from here to here between these two, it would be 87 degrees. Well, notice that P, angle P, well, you could also write it as angle OPR, where P is the vertex. OPR, where P is the vertex. Well, let's look at the name. Hold on a second. Let's look at the name. Angle O to P to R. O to P to R. Well, how would that correspond here in think? Well, it would be H to T to K. And of course, which would be the vertex of the angle? If P is the vertex, then I know that T is the vertex. H to T to K. Well, here's H to T to K. H to T to K. Okay? H to T to K. And what's the vertex of that? Well, the vertex is right here. Here's angle HTK. T is the vertex. So if angle P is 87 degrees, then we know that angle T is 87 degrees as well. Angle T is 87 degrees. Next, let's take a look at angle W. Angle W is 165 degrees. Should put it right there. So I know that the measure in degrees from this, between these two segments, is 165 degrees. Well, wait a minute. I can call it angle W, or I can call it angle OWE. Angle OWE. Well, let's look at the name again. Here's O to W to E. And where's the vertex? What is the vertex of that angle? If you guess W, you guessed correctly. OWE, where W is the vertex. Well, we got the second, third, and fourth letter. So it's going to correspond to think. Second, third, and fourth letter. So it's going to be angle HIN. Angle HIN. Well, here's H. Let's highlight that. Here's H to I to N. H to I to N. And the vertex is I. And I know that the vertex of angle OWE is 165. So then the vertex of angle I is also 165. Okay, and that would go right there. And other than that, for right now, we don't have any more information that would help us find the other angles. And that's okay, because all they wanted to know is that if they give us angle P and W, which angles could we figure out in the congruent polygon right next to it. All right, guys, good job.